Hello everyone, welcome back. Today we have 27 remove elements. It says here that we're given an integer array nums and an integer val. From here we are to remove all occurrences of val in nums in place. And the order of the elements may be changed. Then return the number of elements in nums which are not equal to val. Now, basically, so I brought the examples in here. So we are given some nums and we have some value which we want to remove from nums. We want to maintain the relative order. So in example 2, for instance, we have the removable value is 2. So if we remove all the 2's, the relative order of the remaining items 0, 1, 304, 0, 1, 0, 1, 0, 1, 403, 0, 1, I guess. So that is not the relative order, but if you notice, what we're outputting is an integer. So ultimately, we are returning the number of elements which does not equal the target value. So that's 1, 2, 3, 4, 5. All right, so let's try an example here. The way we can do is we can maintain some pointer I equals 0 to start, and we want to fill it. We want to fill this array in place, whatever the input array is, we want to fill it only. And then we can have some other iterator, like we can call this a j, any other value, and then we'll check, okay, so for that number at this position, and in fact, we don't need another iterator, we can say, okay, our first number is 3. Does this match the number we're trying to remove? It does, so that's all right. We just continue. Next number is 2. Does this match the number we're trying to remove? It does not. That's great. We can use this guy. The way we can use it is insert it at our next insert point, which is 0. So let's add this to here at 0. And now this next insert point becomes 1. All right, so we have another 2. 2, again, does not equal 3, which is the number we're trying to remove. So that's great. We found another one. Let's add that to our next insert point, which is 1. Okay, and make sure to increment our next insert point, and now that is 2. All right, our next value is 3. 3 does match the value we are trying to remove. So in this case, we do nothing. At our point, once we're done, do you notice that the next insert point is 2? And that is the index. However, because the index is 1 less than the length, this actually becomes the number of elements which we have, which are not equivalent to the number we're trying to remove. So this 2 matches this count. And that is what we can return to. And that's our answer. All right, so now let's check the second example. Same thing. We have an insert point, and this time for the insert point, let's do it like this. Okay? And the iterator, let's do it like that. So 0. Is 0 equivalent to the number we're trying to remove? It is not. That's great. All right. Let's add the 0. Let's add the 0. This is 0. And we can move our insert point to 1 index. Okay? Now, once again, 1 is also not equivalent to what we're trying to remove. So that's great. We can insert the 1 and then move our insert to the next position, which is 2. At this point, 2 does match the one we're trying to remove, so that's all right. Let's continue. Now we're here. 2, once again, does match the one we're trying to remove. So again, let's continue. All right, and now we're at 3. 3, finally, so these we remove. finally, we're at a number that we're not trying to remove. So this can finally be added at the next insert point, which is over here. So let's add the 3, okay? And make sure to increment our next insert point. Okay, and we've used up the 3, so now let's go to the 0. 0 is not something we want to remove, so that's great. Let's also add the 0 to, is that okay? Yes, it is. Let's also add that 0 to the next insert point, which is over here, at which point we must remember to increment our insert point. And the next insert point is here. Our next value is 4. We're not trying to actively remove the 4 because that's not a 2. So we can add the 4 to the next insert point down over here, and then make sure to increment our insertion point. Our last number is a 2, which is something we are trying to remove, so we don't have to do anything. At this point, we have 0, 1, 2, 3, 4, 5. 5 is the next insertion point, and we have 1, 2, 3, 4, 5 numbers. So we can return that directly. All right, so let's translate this to code. We're tracking some insert point, which always starts at the beginning, and we're saying, okay, for every num in num, is this number, if num is equal to val, then we want to remove it. So, in fact, what we're actually trying to do is only if the number does not equal the number we're trying to remove, then only do we want to insert it into our next insertion point, the current value. And once we do, let's remember to increment our insertion point. And believe it or not, that's it. that basically represents what we did here. And then we just return the I because the I is the next insertion point, but also represents the count of numbers, which was not equivalent to value or val, which is the number we were trying to remove. And let's not forget that the time in this case, we're going through all the numbers once, so that's linear time. And for space, let's see, we're using some constants like I and num, and so space is O of 1. Let's submit. And there you have it. So once again, 27 remove elements. Thanks so much. Happy coding. See you next time.